Hello. In this video, we're going to be looking at the magnitude and direction of a vector. Okay, so as a recap, last time we looked at how we can represent vectors. So for example, if we had the vector A, which I say is, say, 2i, no, 3i add 4j, right? 3i and 4j. We represented that on a graph, right? Say here, on an xy axis, right? And so we use this I and j like notation, right? These vectors I and j, but essentially the I represents the x part and the j represents the y part. So if we had 3i, that's 3 along the x-axis, so it'd be 3i here. And then for 4j, that's 4 on the y-axis, so it'd be up 4, say up here, right? So 4j. And so then the point, the coordinate, if you like, was there, right? 3i, 4j. And so we connected it from the origin. And so that is our vector, right? That is our vector A. Okay, and so that represents the vector graphically, right? To see what the vector's saying. There. Okay. Cool. So we looked at that last time, how we can sketch vectors in this way. Right. Okay. But I guess if you recall what I also said at the start of the section, and you probably would have seen it at GCSE. That more generally, a vector is a quantity that has both a length and direction. Okay, and we used the example of what was it, displacement versus distance, where if you moved 10 meters forward, that's positive 10, but then if you moved 10 meters backward, it was minus 10. So that negative accounts for like going in the negative direction, right? And that's the whole idea of a vector. So the length, the amount you walked physically, was 10 meters, right? So 10 was the length, but the direction is the sign, right? So if you go in the opposite direction, it'd be negative, right? And that's kind of what a vector is, right? The direction and the length there. Okay, but I guess in this example then, what exactly do we mean by length and direction of a vector like this, right? What exactly do we mean? Okay, but let me then just draw this vector out more specifically. So it looks like this, right? We have a vector, the vector A there, and so then if we consider firstly the x component, that was 3i, right? And then we go up by 4j, right? And actually then this vector creates a right angle triangle, and the hypotenuse is the vector itself. So that was 3i and 4j, right? Okay, cool. So then what do we mean by length and direction? Well, the vector is saying if we start here, right, and end there, right? The vector is basically the path from the start point, so one end of the vector, to the other end of the vector, and so the line between the start and the end is the vector, right? It's saying how do we get from the start to the end. It's basically the vector gives us the path, right, from one end to from one point to another point, and it's telling us the path to go along. It's like basically like a line, right? And so then if we look at if I guess simplify this triangle even more. Let's do it down here, right? Well, obviously the x part was 3i, but in numerical terms it's just 3. We're going 3 along, right? And then we're going 4 up, right? So the 3i means we're basically going 3 along, and then the 4j basically means we're going up by 4. So we get this triangle as well, where you go 3 along and 4 up. And so then the length then, this is the vector then, the length of the hypotenuse then, which is the vector, Well, that's the length, isn't it? The distance, right, of the vector is the length of the line, which is the length of the hypotenuse of this triangle, right? But we know we can calculate that though, can't we? We can use Pythagoras theorem. If I call that then the length, right? The length to be the hypotenuse, then we can therefore say that the length right, is going to be, if we look at this triangle, the length by Pythagoras is going to be the two sides all squared, right? So it's going to be the root of 3 squared add 4 squared, right? If I do that, then I'll get root 9 and 16, which should be root 25, which should just be 5, okay? So the length then is, we can say, is 5 then, right? So that's telling me then that the length of the vector, so the length of the path, right, to get from one point to another, has to be 5 units, right? Could be 5 meters or whatever, but it's 5, right? So the length then is 5. Okay, so that covers one question about the length of the vector, but then what about the direction? Okay, well, if we stick with these triangles, well, the direction we can think of as a trajectory, right? So if I have this angle here, the trajectory, in other words, if we start from the floor, right, or from the horizontal, right? If we start from the horizontal, right, at the base there, and then we make an angle towards the vector, right? And that angle theta there, that is the trajectory. You can think of that then as the direction. So the angle a vector goes up in, that angle is the direction of the vector, okay? It's telling us the projection of where to go up in, okay? So then that angle theta then is going to be my direction, okay? So I'll do it down here. Direction is the angle theta. Okay, but how can we work out theta? Well, very similarly then to Pythagoras theorem, we can use other properties of a right angle triangle, namely SOHCAHTOA, right? So I can use SOHCAHTOA, I can use tan, because this 4 is going to be the opposite, and the 3 here is going to be the adjacent side. So I can use tan, right? So therefore then, tan theta is firstly going to be opposite over adjacent, that's going to be 4/3. And therefore then theta is going to be inverse tan of that, which is 53.1 degrees, right, to 1 decimal place, right? So then the trajectory is 53.1 degrees, right? So that's telling me the direction, right? So that's telling me so the angle is telling me the trajectory, or the angle to go up in, and how far we need to go is the length, right? So with these two combined, we can then deduce the vector, right? So remember, as we discussed, a vector has length and direction. We can work both of those out, okay? And then therefore we get the story of the vector, right? So the length to how far the path is, and the angle is like the trajectory of the path, right? So where to go up in, okay? So to summarize then, if we have a general vector then, say a vector, so if we have a vector AI plus BJ, well then if I then draw that diagram, right, so if I have again that vector, right, AI and BJ, so then if we do a similar triangle, well, firstly the X component is going to be the I part, so that's going to be AI, and then upwards is going to be BJ, right? And so then if we have this vector AI and BJ, right, A and B are just the coefficients, right, the X and the Y parts, then therefore we can say that the length in general is going to be the Pythagoras, right? If we think of this as a right angle triangle, the Pythagoras, if I get rid of the I's, right, if I get rid of this and the I and the J, the physical lengths we have, right? If we don't, the length, the numbers we have is just a and b. So therefore, the length, which is the hypotenuse, right, which is the vector, the length of the vector is just going to be the square root of the squares of both components, so the a squared and the b squared, right? So that's the length, right? And that again comes from Pythagoras. So then this will give me the length there, right? And then the angle swell is going to be theta. That'll be the direction. So then the direction is angle theta. Okay, and you can find that by tan theta. It's going to be the opposite, which is b over a. Okay, and yeah, and so that angle is from the x-axis, right? It's from the horizontal, right? So we measure the angle from the horizontal line here at the base, right? And then how far we get to is the angle, right, theta. So yeah, so these are the two components, right? The length and the direction. That's how we find the direction and the length of a vector, right? So if we're given a vector, we can find its length and its direction. Yeah, and we will look at some examples of that in a second. But I do need to be some notation to be a bit more precise. The length, right? More specifically, the length of a vector is called the magnitude. Okay. Okay, so it's called the magnitude, and it's just a fancy word, and the notation, so we denote it by what the two lines, then an A, right? So the length of a vector, which we call A, the length of the vector is called the magnitude, and it's denoted by this sort of two lines, right? Two vertical lines, and then the vector in the middle. Okay. So in terms of notation, then, if we were to go back to this example, the first example we looked at 3i and 4j, and so the length or the magnitude of this vector a here, we could say mod a would be 5, right? So remember the length here was 5. So we can use the notation to represent the length or the magnitude of the vector. Okay, cool. Okay, so final thing I need to talk about. Actually, let's do an example, right? Let's do another one. So let's say we now have the vector b, which is 6i minus 2j. Okay. So then, if we were to represent that, that'd be so be 6i minus 2j. So we're going 6 across, then minus 2 down. So it'd be minus 2j, 6i. And so that's the vector 6i minus 2j, right? Cool. So then the length, well, if we just consider the numbers, right, we can also consider the triangle. Well, we're going 6 across and 2 down, right? So it'd still be 2 down there. And so by Pythagoras said, the hypotenuse here is the length. So we can say that the length or the magnitude of the vector b, right, which is the length, that's going to be the root of the two sides squared, or the two components squared. So 6i, the number 6, that'd be 6 squared. Then we're going to add the other part, the j component squared, so that'd be minus 2 all squared, right? So then that would be 36 add 4, which would be root 40, which goes to 2 root 10. Okay, So that's the length of the vector, right? The magnitude of the vector, 6i minus 2j. And the angle, right, the angle is going to be theta then there, right? So the angle theta, which is going to be the direction, that's going to be then, if you do, say, tan, so it's going to be tan theta is going to be opposite, which is 2 over hypotenuse, over the adjacent side, which is 6. So then if we do inverse tan of 2 6, we get 18.4 degrees. Okay, so that's my trajectory, right? That's the angle it makes. And I guess more specifically to 1 decimal place, right? I can say it's going to be below the x-axis, right? Because if you think about it, the x-axis, right, is the x part, right? That's the x-axis, right? And then we're going below it, right? So it'd be below the x-axis, okay? Again, you can think of it, if I draw it on a 4-quadrant grid, right? 6i would be there, minus 2j would be there. So then my vector would be there. The angle there, hopefully you can see, if that's the x-axis, it will be below it, okay? So we're going underneath. So I can specify the angle is below the x-axis, okay? So there we are, okay? Cool. Okay, and so that represents the direction. Okay. Cool. Usually they will tell you where to measure the angle from. We'll see more examples like that, but the whole idea is the angle in this way gives us the direction of the vector. So you can see the length is the magnitude of 2 root 10 and the direction is the angle 18.4 degrees. Okay, so lastly, before we jump into some examples, we need to look at something called a unit vector. Okay, so a unit vector is what we denote the vector A with a funny little hat, okay? We call it A hat, right? And this is a unit vector, and what this is saying is a unit vector is of a vector A is going to be the vector A, but we're going to divide it by its length, so it's going to be A over the modulus of A, okay? And so the idea is then a unit vector has magnitude 1 or length 1. So basically, when we're dividing a vector by its magnitude, we just get a magnitude of 1, okay? You can think of it very, very, very similarly to a unit circle, where we looked at in the 10th chapter, I think, where a unit circle is a circle, but the radius is 1, right? And so the unit circle, the unit part of it means it has 1, right? A unit 1, a length of 1. So the radius is 1. Very similar concept to vectors. A unit vector is where the length or the magnitude of it is 1. And so in order to do that, we divide a vector, a normal vector A, by its length, okay? And that gives us the unit vector. And the idea is then, the unit vector gives us the direction part of a vector. So obviously we have vectors are length and direction, as we just discussed, but if we take away the length part, if we divide by its length, we just get the direction part. So in essence it kind of just tells information about the direction of the vector, okay? But essentially unit vector, you find its length, then you divide the vector by its length. But we will look at some examples, okay? Okay, so talking of examples then, let's have a look at this one. Okay, so in this example, we are given that the vector A is 3i and 4j, and the vector B is minus 2i minus 4j. First of all, it wants me to find this double line of A. So you should know, as we looked at it, it's asking for the magnitude or the length of A. So then if I were to draw A again, say on the diagram, where we're going to go 3 across, right? 3i means going 3 across on the x part. And then we're going to go 4 up, right? So 3 across, 4 up, And then there we are, the vector is the sort of the hypotenuse, that's the vector A, right? So 3 and then 4 up, okay? But then we can see that the length of it, right, the hypotenuse is going to be the length of the vector, which is this double line A. So then if we do that, then we can see by Pythagoras it's going to be the root of the two sides squared. So it's going to be 3 squared add 4 squared. If we put that in the calculator, we get 5, okay? And so there we are. That is this is the magnitude of A, okay? Cool. Part B. It's then asking us to find a unit vector in the direction of A, okay? So it wants us to find the unit vector of A, okay? And so this is going to be this A hat, right? This A hat. And so this is going to be the vector A, which is going to be 3i add 4j, but we're going to be dividing it by its length, right? So it's going to be divided by 5, okay? So you can think of it then as a fifth of the vector. So a fifth of 3i add 4j. And then essentially we're dividing everything by 5. So 3 over 5i, 3/5 I, add 4/5 j. And that is my unit vector, A hat, okay? So that's in essence how you find a unit vector. So you find its length of the normal vector and then divide by the length, okay, in this way. Okay, and so there we are. Cool. And by the way, unit vectors, as you can see in this question, the unit vector will always be in the same direction as the normal vector, right? So if we have the vector A, the unit vector of A will also be in the same direction, but we just made its length 1. That's the whole idea. We preserve the direction of a vector, but we just make its length 1, which might be because we want to make we want to make it simpler, because obviously we might have large numbers. So if we reduce the number by making the length 1, then we can clearly see the direction. But we'll look more about that later on. Okay, part C, we need to find now the exact value of the double line of 2a add b. So 2 lots of vector A add vector B. Well, firstly, let's actually compute this vector 2a add b. Right, 2a add b. So it's going to be 2 lots of vector A, which is 3i add 4j. And then adding on the vector B, which is up here, minus 2i minus 4j. So minus 2i minus 4j. So then we can just firstly expand the bracket, right? So 2 times 3i by 6i. 2 times 4j be 8j. And then minus 2i minus 4j. And so then if we sort of collect the like terms, 6i minus 2i be 4i. And 8j minus 4j be plus 4j. And so therefore then we can start to compute the magnitude of this vector here, of 2a plus b. And that's going to be the length again. So the length is simply the square, the root of the square of both parts. So 4 squared add the 4 squared, right? So then if we compute that, put that in the calculator, we get 4 root 2, okay? And therefore that is the magnitude of this vector here, okay? So you can compute the length very simply, right? If you've got the vector, you just root it and then you square both parts, right, of the vector, the I and the j part. Cool. Okay, we've got this example then. So it's asking us now to find the angle between the vector 4i and 5j and the positive x-axis. Right, okay, so if I then, obviously, if it's talking about angles, I'll probably need to draw the vector then to see the angle. If I draw it then, say, over here, well, the x-axis is going to be there, the y-axis there. So 4i and 5j, that's telling me I need to go 4 across, so 4i, then 5j up, and therefore the point is there, so my vector is going to be there. That's my vector. Well, Okay, then the angle between the positive x-axis, so it's going to be there, right? The angle theta there. So I just need to find that then. Well, okay. So then I can think of it as a triangle, of this triangle, right? So I have the same angle theta, but if I'm going 4 across, that's just going to be a length of 4 there. And then 5 up is going to be 5 there, okay? Upwards. Okay, then I can just use a bit of SOHCAHTOA, right? Because that's going to be a right angle triangle. So then I can find the angle by doing tan theta, which is going to be the opposite, which is this 5, over the adjacent, which is 4. Okay, so therefore theta is going to be inverse 10 of that, which is going to be 51, sorry, 0.3 degrees to 1 decimal place. So that's the angle then above the positive, so I'm going to say above the positive x-axis, okay? So there we are. So that indicates the direction, right? So the trajectory is 51.3 degrees above the x-axis. That represents where the vector's going, okay? Okay, cool. Let's have a look at this question then. In this example, we are told a vector A has magnitude 10 and makes an angle of 30 degrees with J. Find the vector A in IJ and column vector format. Okay, so, right. So we've got given the diagram for it here. Now, I'm going to replicate that again, actually. So, make it a bit bigger. So we have the vector A and then this angle 30. Okay, the vector A then, but this vector A, first of all, this vector A, that's the line, right? The vector A is the line, but we're told the magnitude of the vector is 10. That's going to be the length of the line, right? So we can say that this is going to be 10, the length of the line, right? And so the question is talking about finding A in I and J in vector format. So what that means is we need to express A in the form of xi and yj, right? So we need the I and the J component essentially. Well, okay, again, if we have the vector A here, then the I component is going to be how far it's basically the x coordinate, right, or the x part. It's going to be there then, so that's going to be xi, and then we go up, and that'll be the j component or the y part, so yj. Okay, so if we consider then, if we do it to this diagram then, right? So we're going to go some length x, we're going to go x across, right, and then y up. Okay, well then you can start to see a triangle form, right, hopefully. Well, then it's this angle 30 here, but we want the angle in the triangles. We want this angle here, right? But actually, if you notice that overall, the two angles here in the triangle, say theta and 30 outside, that has to add up to 90, right? And so therefore then, this is going to be 60 then, right? This is going to be 60 degrees. So then we obtain this triangle here, right? So this is going to be x, this is going to be y. We have the length of 10 and the angle of 60, okay? And there we are. So now we're in a position where we got the length of the vector and the direction of the vector, right, which is 60, okay? So now actually we can use some SOHCAHTOA to actually find the original x, the I and the j component, right? We used to doing the other way around. Like in the other question, we were given the I and the j component, and we had to find the angle. And in the other question, we had to find the length. But this time we got the length and the angle. Now we need to find the I and the j part. So we're going in reverse, and we can go in reverse because in this example, then we can use SOHCAHTOA to find the x or the adjacent part, and the y or the opposite part of this sort of triangle here. Okay, so if we do that then, well, firstly, to find x, right, we know that 10 is the hypotenuse, right? If I label this the hypotenuse. So then we can use SOHCAHTOA, we can use sine, so sine of 60. to be opposite, which is going to be y, over the hypotenuse, which is 10. So therefore y is going to be 10 sine 60. If I put that in the calculator, then the y part then is going to be 5 root 3. And then likewise for x we can use cos, so then cos of 60 is going to be adjacent, which is x over the hypotenuse of 10. So therefore x is going to be 10 cos 60. If I put that in the calculator, that comes to 5, okay? So therefore then, I can then say my vector A in this sort of format then is going to be 5i, so that's going to be the x part, right? 5i add 5 root 3, which is the y or the j part. 5 root 3 j, okay, and there we are. And then we can, and then remember, we can also write this as a column vector form. So then it's going to be 5 on the top, then 5 root 3 there. Because again, the I part represents the x, right? There. And the j part represents the y part. So how far up we go, which is there, okay? So that's essentially what it all means. And there we are. So we can work backwards as well. And if we have a length and the angle, we can then use SOHCAHTOA to find the original vector, right? So the I and the j part, right? In this way. Okay, cool. Cool. I just want to briefly touch on this because I think it might confuse a bit of people. Specifically, this part of the question here. It's talking about making an angle of 30 with j. Now, this is a bit weird. It didn't really say 30. It didn't say 30 degrees with the y-axis. It said 30 degrees with j, the vector j. That effectively does mean the same thing. It's because remember, j is the y-axis, right? Remember, j represents the y part. But when we're dealing with vectors, it's the angle between two vectors. So they're a bit funny with it. But remember, all you got to remember with this sort of thing is that j represents the y-axis essentially, right? So an angle of 30 with j. This is effectively j, right? The j vector. It just goes straight up. That's the y-axis effectively, right? You can think of it like that. And then therefore an angle of 30 would be there, okay? Which we can see there, okay? It makes 30 degrees with the j vector or the y-axis, right? They're effectively the same thing, okay? So yeah, I thought I'd just go over that. That's what that means, right? An angle of 30 with j means a 30 degrees effectively with the y-axis, okay? Right, okay. Okay, let's have a look at some exercises then. And I do want to go over this sort of question. This is a very common exam question, right? And it isn't that bad once you get practice and you understand what's going on. But it's effectively the same thing to do with magnitude. So we're going to be doing the Pythagoras or the square root business. But there's a bit of algebra, right? So there's a little spanner in the works, but we can manage. So we're told that the length of the vector 2i minus k lots of j is the length is 2 root 10, right? So the magnitude of that vector is 2 root 10. We need to find the value of k. So we're going to do the same sort of thing, right? We're going to but the same sort of thing as if k is just a number, right? So we can do the length as normal. So the length or the magnitude is going to be the square root of the two components, the I and the j component. So 2 squared add the minus k squared, right? And then that's going to equal 2 root 10. Okay, cool. Now we can simplify the square root inside. So 2 squared is going to be 4, and then minus k all squared is just going to be positive k squared, right? Again, minus k times minus k. Well, the negatives cancel because negative times negative becomes a positive. So we get positive k squared. Okay, that's just to I know it might be like a little bit of a moot point, right? But I do want to clarify and emphasise that. It might be a bit of a basic algebra, but don't get tripped up on it, okay? So 4 plus k squared is going to be 2 root 10. Now at this point, we can effectively square both sides, right? To get rid of the square roots. So then we can say that k squared of 4 is going to be 2 root 10 all squared, okay? And so that's going to get us k squared plus 4 is going to be, if I put 2 root 10 in the calculator, all squared, I get 40. Okay. So therefore then, I can subtract 4 to both sides. So then k squared is going to be minus, no, it's going to be 36. So then k is going to be plus or minus root 36. Well, root 36 is 6. So we get plus or minus 6. And so that is my answer. So k is plus or minus 6. Obviously, I should probably I should check the question to see if I can eliminate if it's plus or minus 6. They've not specified anything about k, and actually I did check the answer to the question, and that is correct. But the question from the textbook is just it's a bit funny. Some of the questions from the textbook aren't worded the greatest, so some of it are a bit incorrect. So there are 2 values, right? So, and it's plus or minus 6. Okay, both of those are fine. Okay, and that's the whole idea, right? Again, we just calculate the magnitude as normal, even if we have some unknown letters, k. We do the same process, and that's how we do it. But hopefully you can understand that. That is a common exam sort of question or strategy to be able to do this sort of thing, okay? And then, because it's so important, I'm going to do another question, okay? In this style. So now we have the magnitude or the length of 3i minus k lots of j again. It's now 3 root 5. And again, I need to find the value of k. So then I'm going to because it's the magnitude, and that means I need to do the square root of the 2 parts all squared. So it's going to be 3 squared add minus k all squared equals 3 root 5. I can then simplify the bracket, the inside the root, by expanding the brackets or whatever. So 3 squared is 9. Then minus k all squared is going to be plus k squared equals 3 root 5. Then I'm just going to square both sides to get rid of the square roots. So that's going to be k squared of 9. It's going to equal 3 root 5 all squared, which would get me on the calculator 45. Okay, so therefore k squared add 9 is equal to 45. So then if I subtract 9 to both sides, k squared is 36. And again, k is then plus or minus 6. Okay, if I square root both sides. And that is my answer. And again, same funny question. Those are the 2 values of k. So the questions was worded a bit weirdly because the answer to the question and the mark scheme is both those values. So there we are. Okay, let's have a look at this question then. Right, sort of similar to the last example we did before we looked at the exercises, right? And in this one, we're told the vector A, which is pi, add qj. So p lots of I and q lots of j are positive constants, okay? And this vector is such that the modulus of A, by the way, the modulus is another phrase for the magnitude. There's a lot of words we can use to describe the length or the magnitude of a vector. But the magnitude of A, which is this, is equal to 15. And it also makes an angle of 55 degrees with I. Now, similar to when I just talked about the J bit in the one of the examples, an angle with I again basically represents the X part or the X-axis, right? So if you think of the X-axis then as just I, then the angle of 55 is going to be looking like that, right? So it's going to be 55 from sort of the X-axis, right? That's effectively what it means by making an angle of 55 degrees with I. With that in mind then, so then again, a very good idea to sort of draw the vector, right? What we've got going on. So an angle of 55 degrees with I. So I is going to be there. So then 55 is going to be there. And so then this is the vector, right? This is the vector A. And the length of that is going to be, the length of that is 15. So effectively we've got the triangle then of this. So the angle of 55 here. And then obviously that's going to be the I part. So it's going to be pi and then this is going to be QJ, so the J part. So how far, so then the I part, the P, represents the X, the X part, right? And the Q is the J part, so it represents the Y, right? So we get this sort of triangle here. Okay, if we can draw it a bit neater, there we are. So we've got this triangle of 55 degrees, and the length is 15, right? The magnitude is 15, so the length of the vector, or the hypotenuse, is 15 here. Okay, so effectively then we can find P and Q, right? Okay, so then we can use SOHCAHTOA, right? So firstly, we can use sine of 55 degrees. That's going to be opposite, which is the Q, over the hypotenuse of 15. So therefore Q is going to be 15 sine 55, which is going to be 12.3 degrees to 1 decimal place. Okay. Oh no, sorry, not degrees, just 12.3. Okay, just 12.3. No degrees to 1 decimal place. There we are. And then we could do the same for P then. So now we're going to use cos. So cos of 55 is going to be the adjacent, which is the P, which over 15, the hypotenuse. So therefore P, if we times both sides by 15, 15 cos 55. If I put that in the calculator, I get 8.6 to 1 decimal place. And those are the values of P and Q. Okay. And there we are. So again then, in this example, we were given the angle, right, which is the direction part. We were given the angle, and we were given the length or the magnitude. And from that, we can use SOHCAHTOA when we construct our triangle, right, to then find the actual vector, right, the PI and the QJ. So the I and J part, okay. And again, do not be discouraged if it says an angle with I, right? That effectively means the x-axis. And again, if it was with J, it would be the y-axis, right? So just pay attention to that. But yeah, so hopefully that sort of made sense. How I guess make sure you do construct or jot down the triangle we're working with, right? So the angle is 55, right, with I, so the x-axis, so the x part, so an angle 55, and then the length is 15, so that's how we get to this triangle, right? And the P is or PI, the P is the x part, right, because it's the I component, and the J component is Q, so that would be the Y part, okay? So there we are. Okay. Right, so have a look at this question then. We are told here that there are two forces, F1 and F2, and they're given by the vectors F1 is this and F2 is this, right? And we're given a resultant force of R, which is F1 add F2, and then we're told it acts in a direction which is parallel to this vector 2i minus j. Okay, it's quite a lot going on here. First of all, it's asking to find the angle between R and the vector I. So again, the angle between the vector I, that effectively means the x-axis. So it's just going to look like this, right? From the x-axis, right? We want the angle then, if this is the vector R, we want that angle theta, right? Okay, but we need to find R first, so right? But we're given R, which remember is the resultant of the two vectors F1, F2. That means we add them, and we're told to add F1 and F2. If we do that then, so R is going to be F1 and F2. Well, F1 is 3i minus 4j, add F2, which is pi add qj. And so then if we add the I parts, we're going to get 3 add p, lots of I. And then add the j parts, we're going to get minus 4 add q, lots of j. And we can also represent that as a column then. So 3 add p, on the top and -4 add q on the bottom to be the x and the y parts. Okay. Now we can go to sort of looking at the triangle, this triangle here. The problem is we don't know what P and Q is, so we won't be able to find an actual angle because there's some unknowns here. But we are told this, and this is probably the hardest part of the question, right? We're told this resultant force, then this vector here, but which we just worked out, this is in a direction that's parallel to the vector 2i minus j. Now, remember we talked about at the start of the chapter, two vectors are parallel. Obviously, the scalar multiples, right? We will look into that. But actually, with their parallel, that means the direction is the same. The whole idea of two vectors being parallel is that their direction is the same, which means if we can find the direction of the vector this, 2i minus j, so the angle then, right, because remember direction is basically the angle, right, if we find the angle between 2i minus j and the x-axis, right, then that's the same angle between r and the vector I, right, so then that's what we're going to do. So then if we then construct, so then if we sort of plot this vector 2i minus j, right? So then it's going to be 2 across, then 1 down, because it's minus j. So it's going to be 2, then, well, 1 down, but it'd be -1, but 1 down. So then we get this sort of triangle here, right? And so that is the vector 2i minus j, right? And so then the 2 is the x-axis, right? It's the x part, right? If we remember, if we were to plot this on an xy grid, it'd be 2, right? It'd be 2 on the x-axis and then -1 down, and there we are. So then the angle between from the vector I, which is the x-axis, I'll make a note. It's basically the x-axis, right? Because remember, I is all to do with the x-axis, the x part, right? So then the angle between I, which is the x-axis, is that angle here, right? So it's going to be this angle theta here. Okay, hopefully you can see that. So therefore then, we can find this angle theta then. So then we can say that tan theta, if we do SOHCAHTOA, well, the opposite is 1. So it's going to be opposite over adjacent, which is 2. So a half. So therefore, if we do inverse tan, we do inverse tan of a half, which is 26.57. I'll round it to 2 decimal places. Okay. So that's my angle then, theta. So that's my angle theta between the vector I. Okay. There we are. Okay, so again, I represents the x-axis, right? So there we are. Oh, I should say technically below vector I. Okay, because obviously, again, we're below the x-axis, so we're below I. Okay, but anyway, that's my vector then. So therefore then, because this vector 2i minus j, we're told is parallel to this resultant vector r here, because they're both parallel, they have the same direction, meaning if the angle, right, of this vector is this theta here, if the angle is 26.57, with this vector, it has to be the same angle here, because the direction has to be the same, and the direction is the angle, right? So because they're parallel, both angles they make have to be the same. Okay, so therefore as r is parallel to 2i minus j, both have the same direction. So r makes an angle of 26.57 degrees with the vector I. Okay, and again, that just means it's on the I is the x-axis, so the angle it makes with the x-axis. Okay. Okay, right. So that's probably the hardest part of the question. Now, part B then says, show that P at 2Q is 5. Now, quite random that is, so just get this random equation out of nowhere. But now we're gonna look deeper into this idea of being parallel to this vector here. Now, I also said that in order for two vectors to be parallel, they're multiples of each other. So if we have two vectors AB that are parallel, right, then they're scalar multiples, right? So A is going to be a multiple of vector B, okay, and that would mean they're parallel. We're going to do that here then. So R is parallel to the vector here, 2i minus j. But we worked out R already. R is this 3 add P minus 4 add Q. So then, as R is parallel to the vector 2i minus j, we can say that therefore the vector R, which is 3 add P and minus 4 add Q, is going to be a multiple, right? I'm going to call the multiple K. So it's going to be a multiple of this vector here. Now, as a column then, that's going to be 2 minus 1, okay? So 2i minus j is equivalent to the column 2 minus 1 there. Well, then at this point, it's sort of just getting equations, right? Because then, if we firstly multiply this right side vector, column by k, we're going to get 3 add p minus 4 add q is going to equal 2k minus k. And then from there, we can compare the two components, right? The top and the bottom component. So then we get p add 3 is equal to 2k, and q minus 4 is equal to minus k. And actually, these are simultaneous equations, right? Now, we need to show this equation here. So we already have P and Q. There's no K here, so we need to get rid of K. So I can actually then probably times the second equation by 2. If I do that then, I get 2Q minus 8, which is minus 2K. And then if I reduce the first equation, we get P add 3 is equal to 2k. Then we can add them, right? Because then minus 2k add 2k goes away. There's no k left. So if we add them, we get that 2q add p minus 8 add 3, that's minus 5, equals 0. Because then minus 2q add 2q, no, minus 2k add 2k is 0. So there we are then, we get P add 2Q minus 5 equals 0. So P add 2Q equals 5. And there we are, we get that equation they wanted. Cool. Then we go on to part C, and we're told now that P is now 1. And then it says to find the magnitude of R. Right, so that shouldn't be that difficult. Now, so P is 1, firstly. Well, actually, we can sub that into here. Right, we can sub P into this equation here that we just found. So therefore, if I substitute P is 1, we get 1 add 2Q is 5. So then 2Q is going to be 4. So therefore, Q is 2. Right? Okay, then it's said to find the magnitude of R. If I remind you then, the vector R, which we worked out here, this is R, right? R is 3 add P and minus 4 add Q. And so then if I put in P is 1 and Q is 2 into here, I get 3 add 1, minus 4 add 2, which would be 4 minus 2. Right, and that is my vector R. And then, therefore, the magnitude of R, again, it's going to be the x part and the x part and the y part, right, all squared together. So it's the square root of the x part, so 4 squared. Add the y part, or the j part, which will then be minus 2 all squared. If I put that in the calculator, then I get that the magnitude is is 2 root 5. Cool. And by the way, you can, because we can convert between I and j and column vector form, we can also find the magnitude of a column vector in this exact same way. If we were to convert that back into I and j, that'd be 4i minus 2j. And then from there, hopefully you recognise it'd be the square root of the I part squared, so it'd be 4 squared, and the j part, which would be minus 2 squared, and we get the same answer. Okay, so we can also find the magnitude of a column vector, right, in this exact same way. Okay, and there we are. So that's the magnitude of r. Now that's a very tricky question. I've been very tricky, but hopefully now that you've seen it and you've seen me go over it, it sort of makes sense. I'd probably say this is the hardest part. Again, recognize part A, recognizing that if two vectors are parallel, their direction and therefore the angles they make have to be the same. That allows us to then find the angle between r and I, which is basically the x-axis. So r and the x-axis, which is there. Okay, so have a look at this question, which is nicer, okay, than that one. So okay, we are given now a triangle PQR, where PQ is 4j, PR is 6i minus 8j. It's asked us to find the size of angle QPR in degrees to one decimal place, firstly, and then the area. So, what on earth has this triangle got to do with, how can I find size and area when I've got vectors right up the sides? What am I doing here? Well, the beauty that we just learned is that we can find the length of a vector. Now, the vectors, PQ, that represents this side here, right, P to Q. Also, P to R is that side there. We know how to find the length of a vector. It's the magnitude. So we can say that firstly, the magnitude of PQ is going to be, well, if PQ is 4i and j, so then it's going to be the root of the I part, so 4 squared, and then the j part. Now that's 1j, right? There's a hidden 1, so it'd be add 1 squared. And then if I put that in a calculator, I get root 17. And actually that is the length of PQ, the vector PQ, which is this side PQ, right? So basically we can use vectors to also work with shapes to find length and areas and so forth by literally just finding the length of the vector or the length of the side. The length of the vector gives me the length of the side of the shape it's on. Okay, we can do the same thing for PR then. Oh, so the length of the vector PR is going to be the same thing now. So it's going to be the square root of the I part, so it's 6 squared, and then the minus 8 squared. If I do that, then I get 10. Okay, so that's telling me the length P to R, so the side PR is 10. Okay, but obviously the size of angle QPR, so P is in the middle, right? So the angle is going to be at P. I'll call that theta. Well, think back to think back to when we did trigonometry. We used cosine rule or the sine rule to work out areas of a angles of a triangle. But I don't have. I only know two sides, right? And I don't know any angles. I'm thinking if I can somehow work out the remaining side, I can then use cosine rule to work out theta. But I don't have that side. I don't have QR. But I can. Because think about it. I can find the vector Q to R then. I can find that. I'm not given it, but I can find it. Because actually, if I'm starting at Q and ending at R, well, I can't go directly Q to R. But I can actually alternatively go from Q to P, then P to R. And there we are. So I get my vector. And I know what these two vectors are. I know QP and PR. Right? They've given me that. Well, QP, well, P to Q, right? P to Q is 4i and j, but I want q to p, so it's going to be the negative. I want to go the other way, so it's going to be the negative of pq, add p to r, which I'm given. Well, p to r is 6i minus 8j. Okay, but then I just do negative pq, so it's going to be the negative of 4i at j plus 6i minus 8j. Then if I expand it, I get minus 4i minus j, add 6i minus 8j. And so then I get minus 4i add 6i, that would be plus 2i. And then minus j minus 8j will be minus 9j. And there we are, that is my vector qr. But then to find the length of that vector, so the length of the side qr, that's the magnitude of this, the magnitude of qr. And so that's then going to be the square root of the two parts all squared. So 2 squared add minus 9 all squared. So if I do that, I get root 85. And now that is the length of QR, 85. And so that is the strategy when we will see more examples with stuff like this, with shapes, with vectors. That is literally the strategy to find the lengths, okay? To find the lengths of the sides by doing the magnitude of all the vectors. Okay, now we're in a position, it's basically just a trigonometry question now, right? If I look at this triangle I've got all 3 sides and I want to work out an angle, that's cosine rule, okay? So if I do cosine rule then, well, we know that that theta, the angle theta, which I've want to find, that's angle QPR, the angle at P, that's opposite the side root 85. So we're going to get root 85 all squared. So remember, a squared equals b squared at c squared minus 2bc cosine of a. So root 85 squared is the other two sides all squared. Root 17 squared add 10 squared minus 2 lots of root 17 times 10 cosine of the angle theta, okay, which is what I find. Then we just need to sort of have to simplify everything. Well, root 85 all squared, that's just going to be 85, and then root 17 squared is just 17, add 10 squared is 100 minus 2 times root 17 times 10, that would be 20 root 17 cos theta. Then I can add these numbers together to simplify some more. So then 85 is going to equal 17 add 100, which is going to be 117 minus 20 root 17 cosine of theta. So then I can say that 20 root 17 cosine of theta is going to be 117 take away 85. Now that's going to be 32. And so therefore then cosine of theta is going to be 32 divided by 20 root 17. So therefore theta then, if I do inverse cos I get 67.17 degrees to 2 decimal places by rounding. And by the way, we do not need, there won't be a second angle here. Remember when we looked at the sine rule in the trig chapter, we had to consider the ambiguous case, meaning there could be 2 possible angle solutions. But that's only when we're dealing with sine theta. When we're dealing with cos theta, there will only be one solution here. So we don't need to consider anything else. That is the angle, okay? Now, and that's the angle then. Then part C, then said to find the area. Now, the area is going to be half AB sine C, right? So it's going to be this angle here, and the 2 angles next to it is root 7, the 2 sides next to it is root 17 and 10, right? But then, therefore, the area, I'll do it up here actually, the area is going to be half AB sine C, with the angle C, which is theta. So then the 2 sides is going to be half times root 17 times 10 times the sine of the theta that we found, which was 67.17. Oh, that's part C, sorry. So then if we just put that in the calculator, then the area is going to be 19. There we are, 19 exactly. 19 units squared, say, right? But 19 is my area, the triangle. Okay, cool. And there we are. So again, we can, again, it keeps drilling back to what I say in my videos. You do need to be keeping on top of earlier topics, because the questions do like to use multiple areas of the specification, multiple different topics together. In this case, we needed to then use the cosine and the half AB sine C, which we looked at in an earlier chapter with trig. So you do need to remember that. But yes, hopefully that made some sense. Right, we're going to finish off with an exam question. And we are given now the triangle PQR. It's actually not too dissimilar to the last question. The triangle PQR is such that the vector PQ is 3i add 5j and PR is 39 minus 15j. Find the vector QR. Now, it's talking about a triangle. It's probably best to sort of draw it, right? So the triangle has points PQR. Let's just draw a generic triangle, right? PQ. So that's going to be PQR, right? There we are. That's my generic triangle. I'm not worried about how accurate it is, how oriented it is. Just a rough idea of a triangle with my points. So PQ is that vector there, P to Q. I'm given that. I'm also given P to R, which is that vector there. I need to find Q to R, so that vector there. Right, okay. So to get from Q to R then, I can't do that directly because I don't have the vector or the information for it. But I can go the other way. I can go from Q to P and then P to R. So I can say that Q to R, if I use my diagram, which is why drawing a rough diagram is very handy to spot this. Q to R is going to be instead Q to P and then P to R. Well, Q to P, I know P to Q is 3i and 5j, but that's PQ. That'd be that way. I want to go the other way. I want to go from Q to P instead. So it's going to be the negative of PQ, right? Add PR. Now PR is 13i minus 15j. So then minus PQ, that's going to be minus, well, minus this, right? So minus 3i minus 5j, right? Plus 13i minus 15j. Then we could just add the I and j's. So minus 3i add 13i would be plus 10i. And minus 5j minus 50j would be minus 20j. Cool. And there we are. So that's QR. Cool. Then for part B, then it said hence find the length of QR as a third. Okay. So then that shouldn't be too weird either. So then the length, the modular, the magnitude of the vector QR. Then the magnitude of this vector we just worked out. Again, that's going to be the root of the two parts all squared. So 10 squared add minus 20 all squared. If I do that in the calculator, then I get 10 root 5. Okay, cool. By the way, it is 2 marks. I guess there might be some, it said to simplify it, there might be some concern about could you just put that in the calculator. The answer is yes. As the mark scheme, you'll get 1 mark or the method mark for recognizing you have to perform this square root, which is the length, then the final mark, which is here, for the correct final answer. Okay, so once I put my square root in, I can then put that in the calculator. I don't need to simplify it step by step. I don't need to do 10 squared, 20 squared, and then go from there. I can just jump to the answer. Okay, in this case. Right, part C. Now I'm told the point S lies on the line segment QR such that QS to SR is 3 to 2. Right, so now we're adding a point S on the line QR, so on this line here. So that's telling me S, where Q to S is 3 parts, and the remaining part is going to be 2. So in overall, obviously the total part is 5, right? So the total is the whole line QR, right? So then Q to S is 3 parts, so it's going to be 3/5 of the line. So 3/5 is going to be, say, there, right? That's going to be then S. So that's going to be 3/5, right? Then the remaining part from S to R is going to be 2/5, right? And there we are, okay. Now, in this case, it's asking to now find P to S, right? So obviously P to S would be that vector there. I can't obviously find that directly. I need to go and find another path. Well, I can go from P to Q and then Q to S, right? So PS is also PQ and then Q to S. Okay, well PQ I'm given in my question to be 3i and 5j. Now Q to S then, as we discussed, Q to S is 3/5 of QR, the whole line QR, right? As we just discussed up here, QS is 3 out of 5 of QS, so, QR, sorry. So I can say that this is going to be 3/5 of QR. Right. But again, I found QR in part A. QR is 10i minus 20j. So I need to do 3/5 of this. So then I'm going to get 3i add 5j, and then 3/5 of this vector QR, which I found in part A, of 10i minus 20j, which I've circled. So 3/5 of 10i minus 20j. And so then I just need to expand that, right? It's pretty much 3i plus 5j. And then 3/5 times 10i is going to be 6i. And then 3/5 times minus 20j, that would get me minus 12j. Okay. And then I just need to add the I and j's. So 3i and 6i be 9i. And 5j minus 12j would be minus 7j. Okay. And there we are. That's the vector there. So, yes, so that is magnitude and direction, or in other words, the length or and the angle it makes. And yeah, so we will be looking at putting this into more practice later on in the chapter. We will be using especially the magnitude more in the later parts of the chapter. But for now, I will see you next time.